Yeah, recording started. I'll just share my screen, Nikhil, meanwhile. So please don't leave the this thing session because it may not be possible for me to re-admit you. Okay, I'll just go to screen share option. So as of now, 40 are there. Okay, and I believe all of you are aware your first internal it is going to be from 20th. Okay, 20th of this month only. And one more thing regarding that, it will be the common question paper for both the divisions. And what I have discussed, I will let you know anyway. Okay, so today I discussed with other class faculty, Shivkumar Gowda. So what we have discussed is we will upload the question paper in the Google Classroom just 5 minutes before the commencement of your examination. Examination time will be noticed to you. So wherever you are, you can write from there only. It is an open book test. Open book test means copy madlik ನಿಮಗೆ permission, official permission. But questions, so they will not be straight substitution type irodilla. So probably by this time I believe that you know the how tricky the questions are. What we have decided, in fact, unofficially I am telling, officially I let you know. Okay, so individual problem ಅಂದ್ರೆ ನಿಮ್ದು ಪ್ರಾಬ್ಲಮ್ ಇನ್ನೊಬ್ರ ಕಡೆ ಬಂದಿರಬಾರ್ದು, ಆ ಟೈಪ್ ನಾವು ಕ್ವಶನ್ ತೆಗಿಬೇಕಂತ ಡಿಸೈಡ್ ಮಾಡೇವಿ. Okay, ಹೆಂಗ್ ತೆಗಿತೀವಿ, ಏನ್ ತೆಗಿತೀವಿ, we will not let you know, but be prepared. So you understand the procedure of solving the problem, you understand the problem itself. Okay, so which I have told earlier, and make a lot of practice. And all my videos are accessible, and in case I think now there are 45 including Mallikarjuna. Okay, so if anybody is still not able to assess the videos, YouTube videos, I have made a admin. In fact, he will tell you admin in the sense he will not give the SS. That is uh, Chandan Pai. Chandan Pai. So he will be helping you out. I think yesterday somebody has called. I don't remember who has called immediately after the class, saying that sir, whenever I click the link, I am getting that you are not assessed. Okay. So please check with the Chandan Pai. He will help you out. And in fact, I told also before after the commencement of today's class that most of you have already subscribed to my channel. Okay, where the moment I what you say put any video, you will get an alert. Okay, from YouTube. Okay, I think now there are some 30 plus. That also Chandan Pai will tell, because Chandan Pai is also subscribed. Okay, for my YouTube. Of course, I have not this thing doing any sort of, but it is a closed one. Closed one. No other people can able to access. In fact, if you become member, also only free access. I have couple of free access videos as well, so which you can able to see them. Okay, so with this brief this thing, I'll just share my this thing presentation today. Hope you can able to see Chandan Pai. See, people
Yes,
are
sir.
still pouring. This is the last person whom I will be admitting. I think two people are there, Rasool and then Prajwal Gaonkar. Okay, Prajay Gaonkar. Okay, I think, okay, 47. I'll not be entertaining, and henceforth we will just go ahead. Okay, so this is going to be the helical gear which we have started yesterday. I had told this helical gear. Always remember, I'll brush up those who were there last class or not. I'll just brush up. This basically helical gear, opposite hand will get come in contact. So that is opposite hand means always just see on the right hand, extreme right hand side, what you can see. So this is the RH. Okay, RH, right hand side. Why right hand side? The axis of gear is somewhere like this, horizontal. So you just hold the gear, that axis of which gear should be perpendicular to your body axis. Body axis means when you stand, the axis of your body is symmetric with respect to vertical. Okay, perpendicular to the ground. Okay, so to that this thing you hold the gear. If the teeth are descending towards your right hand side, it is called right hand RH gear. And if the teeth are descending on the left hand side, it is called as LH gear. So see, this is the pinion and this is the actually the gear, larger one. So this is LH, but this is RH. So remember, all the time RH will meet LH, and similarly LH will meet RH in this particular whatever figure. And here you can see the 3D so that you can visualize properly. And remember, the contact is progressive. Unlike in spur gears, you have contact throughout the length of the teeth. Okay, one teeth and another teeth, they will, the contact will be full contact at a time. But here it is a progressive means at a time only one particular area, not a full area, only one particular area is there, and when the gear rotates, this contact slowly progresses. So that is why I forgot to tell, the strength of helical gear is very much strong as compared to spur gear. Compared to spur gear, if it is the same power to be delivered, you notice that a small what you say, small helical gear can transmit the same power as that of a spur gear. Okay, small diameter wise. The reason is the contact at a point is only at a one particular junction in helical gear. Like in spur gear, the contact is throughout, so the load coming on the tooth is maximum, so that load carrying capacity of the spur gear is less as comparative to the helical gear. So that is why we generally prefer helical gear wherever the large powers are to be transmitted. If you just open your two-wheeler gearbox, the immediate gears are not spur gear, they are the helical gear. Further gear reduction wherever it is required, there we go for spur gear. Okay, so remember, this is going to be an added this thing. For more details, you can Google search and then make. So this is one added this thing which I left yesterday. I will be just mentioning today. So do recall. Anyway, it is a recording will be there. In case my voice is not coming properly, something like that, so you can able to hear that. Am I audible, Chandan?
Yes, sir. Audible, sir.
Fine. And next, what we have done is we have done this how the axial thrust. Axial thrust means since the teeth are not parallel to the axis, whenever you resolve that normal that resultant force, you notice that one will be perpendicular to the tooth profile, another will be parallel to the tooth profile. Parallel to the tooth profile, that is going to be the axial force, and that is going to get this particular gear arrangement disengaged. Disengagement, that axial force will push the gear away. This will push away and this will push away, so that the gear engagement will not be there. Just to avoid that, what you have to do, you have to provide the thrust bearing. This is called as a thrust bearing. In the bearing topic, we'll just decide. Okay, that also I told how to judge upon. So you have to use your right hand thumb rule. One second. Brijesh, na class ಅಲ್ಲಿ ಇದ್ದೇನೆ, so I'll call you back. Okay, thank you. So how to get this thing? So you have to show your right hand palm, okay, in the direction of rotation, the fingers, and the thumb, right hand thumb will represent the direction of axial force, and there you should have the axial bearings. Okay, so 1 second. I think some two people may be waiting in the lobby. 1 second. 1 second. I'll just admit them. So this is the reason I told people. I think Rangoli is also waiting outside. Kulkarni, Saurabh, Rangoli should come a bit earlier. It's almost 10:40. I don't know. So if you have any problem, Rangoli is leaving. I don't know, leaving or. So please come in a time, Rangoli. Okay, so henceforth this will be a problem for me, because continuity will go, and again I wanted to tell something that I will. If you have any network issue, please sit in a place. I told, sit in a place where you have the better this thing, and again be in time. Just 2 minutes you can log in before, because I can able to this thing. I can understand your network issues and all, so that is why I will not exceed more than 30 to 40 minutes. Anyway, done with. I think I have admitted all. Henceforth, no admission. Okay, so this is what that I have told. So whatever I told previous slide, so here you can just see that. So that is that is FT. So this is FN actually normal, and this is a end thrust or axial thrust. So this has to be what you say, supported by this thrust bearing. So whatever you can see, thrust bearing. So this I had elaborately told in the last class. So please go through that. Okay, so this is again one more actually, that gear forces. So we will try to solve one problem on that. And again, equivalent number of teeth, it is a virtual number of teeth which are equal to the number of teeth equal to spur gear. in a plane perpendicular to the helix angle, that is virtual number of teeth. Please remember, virtual means it is a not real. Please do not round off in the calculation. That I told how that is going to come. That the elaboration is there. Of course, there is no derivation. So z equivalent equal to z divided by cos cube beta, where beta is the helix angle. Okay, I'll quickly go. And then design procedure we have seen. Design procedure is the same as that of spur gear what we have discussed. That is, the first one is going to be the material selection. In case the material is not given in the problem, you can make an assumption. Okay, material, that is, if depending upon the power, please go through that, how to select that. And preferably, if the material is not given, it is a jackpot for you for the academics, because you assume both materials as same. So third step, you need not have to calculate which is going to be the design criteria, because all the time pinion is going to be weaker. That also I have shown. That is one. And the second step is going to be the minimum number of teeth to avoid the interference. Okay, so that is Z1 always. So you refer same thing what you have done in the spur gear, but only thing, you don't keep that Z, you have to take it as Z equivalent using this expression, and do not round off this, because it is a virtual number of teeth. Do not round off, you keep as it is, and further wherever that Z is going to come in the expression, okay, sensibly see that. So if any cos term has come, then again substitute as it is, if it is in the data book or that is in the helical gear section. If you are borrowing from that equation from any other section rather than helical gear, what you have to do, you have to take care of substituting Z equivalent. Okay, so again I told actually, so here in this, in case the center distance is given, you are not supposed to make that assumption of minimum number of teeth, because if you do that, your module will get fixed off. So in order to this thing, so what you have to do, you have to substitute wherever that Z is there in terms of module only, and then try to find out. That is center distance problem I have solved in spur gear. Same thing is also valid, but wherever that Z is there, so that is going to be that Z equivalent. And whenever you use that batch equation and then calculate, please note down that batch equation is for spur gear actually, which is in the transverse direction. So module what you get is M, not Mn. So that M you convert into Mn using this particular expression. One second. This particular expression, Mn equal to M cos beta. Okay, cos beta or cos cube beta, Chandan Pai, just see, I think I did a mistake over here.
Cos beta, sir.
Okay, fine, it is correct then. Cos beta only. Mn equal to M cos beta. Just check your data book parallelly. I left the data book, I told Chandan actually. Okay, so cos beta, you just substitute that and do not round off this, because this whatever you get Mn is in terms of the decimal, that this thing, again you refer the same table where you have referred that standard module, that is choice number 1, choice number 2, choice number 3, same table you have to refer, but that will be normal module. If you have the data book, please see and read the footnote. What is the table number, Chandan? Chandan, what is the table number, that module table number? I think it is 12.2.
Yes, sir.
12.2, page 229. If you see there, that table is valid for spur gear as well as helical gear as well. Okay, helical gear means it will be a normal module Mn. Okay, so any doubt up to here? If no doubt, I'll go further. Anybody? So couple of guys, you can just unmute and then tell if you have any doubt, or shall I continue?
Continue, sir.
Okay, fine, no doubt.
Continue.
Okay, fine. Then again, next step is going to be the step number 3, design criteria. Again, same thing. Okay, only thing is in Y. What is that Y? Y is the Levis form factor. There, in place of Z, you substitute Z equivalent. Okay, and then Z equivalent, do not round it off. Whatever the decimal comes, the same thing you have to substitute and find that, and whichever is the smaller product sigma d into Y. So that is going to be the governing design criteria. And afterwards, the module calculation, this also I have elaborately explained in the yesterday's class. Please note down here, there is a Z is there. So you may get confused. I told Z equivalent and Z. Please note down this Z equivalent equal to Z cos, the previous, what is that? Somewhere, where is that? Z divided by cos cube beta. Z equivalent equal to, or Z equal to Z into Z equivalent equal to Z divided by cos cube beta. Okay, so in place of that, here what he has done is, instead of substituting Z equivalent, so Z divided by cos cube beta he has substituted. Since it is a cube root that is been taken outside and then it is taken inside the bracket, that cube is there. Don't get confused over here. Okay, so this is how it is. Here you have to substitute z only. You have to substitute z only, not z cube, because this expression is in helical gear section. But whatever this y term is there, no, Lewis form factor, that expression is in the spur gear section, where you have the z, that is 0.154 minus 0.91 something for 20 degree and 14.5 degree. That divided by z is there you have to substitute z equivalent, I told. So don't get confused. Okay, you keep on repeatedly listen to this video, you will understand. Okay, and then that is what, so pi into y, so replace, I think I have written everything, z by z equivalent, and then b is going to be b by m. So you had taken earlier spur gear 9.5 to 12.5, here it is 12.5 to 20 mn. Okay, and then for herringbone or double helical gear, it is actually 20 to 30 mn. Remember that. We will, if possible, we will try to solve one problem. And cw, it is the wear and lubrication factor. So generally what happens, since the contact is continuous, unlike spur gear, there is a lot of heat generated, a lot of wear and tear in the helical gear. That is on drawback. Advantage is it can take up more power for same power to be transmitted, compared to spur gear, that is a smaller helical gear can take up same power as that of larger spur gear actually. So since the contact is continuous, so wear and tears are there, that is also been taken in this expression, the derivation of which is again we are not doing here. Okay, there is no derivation done. And again, this is what whatever that previous, again repetitive, and again some of the terms were not this thing. So cv, refer the table. Okay, this refer that, and torque is by this equation, and z you should substitute whichever is the design criteria over here. I think that is what it is been told. And this is the herringbone, this is the herringbone gear. Herringbone means it is a double helical gear. Okay, sometime if the power to be transmitted is more, we go for double helical gear, because in single helical gear power that cannot be transmitted maximum. So we will go again, this is a one more confusing and beauty. So one particular gear will have both hands, that is one side RH, another side LH. Similarly, one side LH, another side RH. Okay, so something like this. Manufacturing, they will not manufacturing together actually. This is separate, this is separate, and again what they do, they put a screw and then make it one unit. Okay, this is the herringbone gear or double helical gear. So here we stopped. So, and again next step, quickly I will tell. Next step is going to be check for induced stress percentage variation. So the same procedure what you did in your regular this thing, no. So the same thing you have to do, that is percentage variation. Again, this formula is not in your data book, please remember that. So it is d2 by d1 difference n1 by n2 divided by n1 by n2. This should be less than 1%. If not, again you have to change this. I think very elaborately I have told. And again sigma I should be less than sigma d. Okay, so what is that? Once after finding the module, you have to back substitute that in all expressions like cv, b and all. Okay, then what you have to do, you have to, in place of sigma d, you find out the sigma, so that is going to be the induced stress. Okay, that has to be less than your maximum permissible strength of that material. If not, you have to alter the value of k, whichever is been told. Okay, so which I have not written here, it is the same actually. In case if it is not, I told actually there are three options. One is material. Before material, there b you can change. Suppose if you have taken 12.5 to 20 mn is there. Suppose if you have taken 15 or 14, you alter that. In spite of that, if you don't get, I think last class somebody has told, in spite of that you don't get, then you check the changing of the material. And material, if it is given in the problem, you don't have that liberty. Liberty means free. You can't change unnecessarily. If the material is given, you have to give. That means it is something like in a what you say, in a competition only, they have in this like examination they have given you some 30-page booklet. You can't say, sir, I 30 pages are complete, I want some more pages, means they will not give. Okay, similarly whatever is the given, in that one only you have to do, in that only you have to do. So you can't change the material. Then only next left out item is you have to go for higher module, like that you should do. And next one is going to be check for dynamic load. Again you have the separate equation for dynamic load in the helical gear section. So page number I have not written. Chandan, can you tell the page number, Chandan?
Yes, sir.
Page number of this 12.26a data book, page number 12.26a, Chandan.
214, sir.
Yes.
214. Okay. 214 page number, correct?
Yes, sir.
Okay, 214, page number 214. So this expression is given, all values, everything is same. That is, C is the dynamic factor, that is E, that is error. K1 is that strength factor. E1 and E2 are Young's moduli. If given, no problem. If not given, don't be panic. You assume the steel material somewhere between 200 to 210. Okay, after that, you should check Fs should be greater than Fd using this expression. Again, same page number, I think, sigma d B into Y into Mn. Okay, please do that. If again it is not, you go for changing the B value. Okay, B value means K you change, and again B will be accordingly, it will be changed. Again, that is iteration. Okay, that I have written. Okay, if again material, if even after this, if it is cannot able to satisfy, like, change the material. If material is not given in the problem, or last option, go for higher module. Again, go for first choice. Okay, this is how you should do the dynamic check. Next one is wear load. I think I have not checked the endurance. Can anybody tell me why I have not taken endurance check here? Endurance, do you remember? That is sigma endurance equal to, F endurance equal to sigma endurance. Okay, that B into sigma, B into M into Y. Do you remember? Spur gear. Hello. Rangoli, Rohan, Chandan Pai.
Yes, sir.
Yeah. Do you remember spur gear? We checked endurance after dynamic. We checked endurance. Here, endurance is not required. Can you tell why it is not required? Here, only
Progressive.
the dynamic check is done, but endurance. Huh?
Progressive. This thing is not the.
I think
Hello.
fantastic. You could able to catch it. Please speak clearly. I think I could able to
Hello.
understand. You got the point. Yeah. Please go ahead. Go ahead. Go ahead.
Progressive meshing is there.
Exactly. Can anybody just mute yourself? Anybody who has understood what he has to? What is your name?
Chandan.
Chandan. I think Chandan could able to grasp was really strange. I think he could able to grasp this. Others, can anybody tell? He told progressive. What do you mean by that? Progressive. What do you mean by
It's
progressive?
progressive increase speed, sir. Not in
Okay.
per gear, it is directly speed increases.
Directly. Pardon me. Directly.
It at on speed increases fastly, sir. In helical gear, speed increases gradually, sir.
No. I think you are. I don't say you are wrong, not correct. But in this context, you are not right. I'm asking why endurance check is not required. I think Chandan told it is progressive. I think I believe he has understood. Others, can anybody pour? Rohan Rangoli. Rohan Rangoli. Is he there or left? Rohan. Rohan Rangoli. Rohan Rangoli. Rohan Rangoli. I think he has left. Rohan Rangoli. He's waiting in a lobby. I think, I don't know, some problem, network issue. He may be admit failed. Okay, I think he's not there. Shiv Prasad. Shiv Prasad.
Yes, sir. Yes, sir.
Yeah, can you tell Shiv Prasad why that endurance check is not required in helical gear? Quickly.
Yes, sir.
Yeah, please.
Sir, you.
Tell me. Your voice is breaking, Shiv Prasad.
Sir, hello.
Yeah, tell me. You are audible. Tell me. Go ahead.
Network on 1 minute.
Network issue. I think even you can chat also. You can chat also. I have come outside. You can chat as well. Shiv Prasad, if network issue is there, you can chat as well. Shiv Prasad also left conversation. Good. Okay, then Pavan Bekani. Pavan,
Yes, sir.
Pavan, can you tell why it is not required? Endurance check is not required here. Endurance check is not required. Can you tell why?
Not getting, sir.
Oh, fine. Leave it. Mute yourself. Mute yourself. I'll just show that. I'll just show. I think I could able to add Chandan. I think I'm sharing. I should stop share and then I think my video will work. Okay. Just look into that. So I'll try to, yeah, I think you can able to see me. You can able to see me some corner, my video.
Yes, sir.
Yes,
Okay,
sir.
just to see spur gear, what happens? They come here, okay, they come and then they just hit like this, hit and then depart, hit and depart. But helical gear, it is continuous motion like this, okay, continuous motion. So there is no hitting. Hitting is not there. In spur gear, they hit and then depart, hit and depart, okay. They hit, they come, hit, and then depart, and again next gear hit and depart. Okay, it is intermittent. It is the contact is intermittent. Helical, it is continuous. Helical, it is continuous. So that cyclic load is not going to come in helical gear. That is why we are not going to check for endurance check. Okay, so that is what is the implication of that. Okay, implication of that. Understood? No, Chandan?
Yes, sir, understood.
Chandan?
Hello.
Okay,
Yes, sir,
fine. I
understood.
think Shiv Prasad. Fine. Okay. Fine. Again, that is the reason we don't check for endurance. After that dynamic, directly we will go for the wear. Okay. So here I will be just ending that. So wear gear again. You have the same this thing, but that equation is in the helical gear section. Please note down that cos square term is there. It is not cos cube. It is a cos square term. Just check, Chandan. 12.26 page 214. It is cos square or cos cube. Chandan Pai.
Cos square only,
Chandan
sir.
Pai.
Hello.
Cos square. Okay. So
Yes, sir.
yeah, right. Thank you. Okay, it is cos square only. It is not cos cube. Of course, there are some terms will get cancelled. Derivation is not there. Further, if you want, you can just go ahead and then do the derivation part. Okay. So FW equal to this, and again Q equal to same thing. And if FW is less than FD, so it has to be greater than FD basically. So just check this. If it is, again, what you have to do in the place of FW in this expression, substitute FD and get the value of K. That K value you locate from the same table. 12.16 and 12.17. That is what is given in this expression. Okay, page 239 to 240. I think I told whatever the profile is there, with respect to that profile, you should able to find out the K value and declare what is going to be the hardness, surface hardness of that gear. Similarly, what you did in case of spur gear. So now the procedure is over. Okay, should I take one small problem or should we? I think my watch. I think now what is it is almost 11. Okay, half an hour I have taken. Should I take one problem? Here the presentation is over. Okay, I'll just discard all. Okay, should I take one of this thing problem? Abhishek Naidu is joining now. Okay, well, we'll take one problem then quickly. Okay, we'll take one problem quickly. So please, all of you, I'll just share that. You copy that. In fact, it is some time back. This thing, you just copy that problem. Okay, can you able to see my screen now? Can you able to see my screen now?
Yes,
Hello.
sir.
Yes, sir.
Yes, sir.
Okay, fine. So it is some question paper. Okay, some question paper. Okay, so anyway, so I'll just zoom a little bit. Okay, so it is actually for 10 mark. So the questions will be like this. Depending upon the marks, you should read the question carefully. I repeat once again. So it is design a pair of helical gears to transmit 50 kilo-hour with a velocity ratio of 4.25 is to 1. Pinion rotates at 1800 rpm. Helix angle. What is this helix angle? Anybody? Helix angle is 15. What is this helix angle?
Beta.
What I told, helix angle?
Beta.
Beta, exactly.
Beta.
Yeah, exactly. Helix angle, yes, thank you. Helix angle is beta, and tooth profile. What is this profile? What is the angle? What is the angle? Is it which angle is this? What we have taken earlier? Just can you recall? Spur gear. It is alpha. Okay, it is alpha is a 20 degree full depth involute. The gears are lubricated randomly. Okay, it is given very specifically. Randomly means sometime lubrication, sometime no lubrication. That is worst case. Okay, intentionally it is given just to check your ability to decide. Okay, can anybody tell me, it is told here design, should we do the design till the end of wear load, or somewhere we should stop? I you can hope you can able to see clearly. I'll zoom on the screen. Okay, so this one only, this top one only you should, I think, hope you can able to see it clearly. Till where you have to do the design? Anybody? Should you do the design till wear load? I told this, you should read the problem carefully and take the decision. Anybody quickly? Anybody quickly?
Sir, up to induce the
Yeah.
strength only, sir.
Exactly. Fantastic. Fantastic. I think he nailed that. Okay. So read that. So check the beam strength only. Okay. Up to here. Beam strength means what? It is just induced strength. Okay. Beam strength only. And again, assume the material also they have given heat treated C30 material for both pinion and gear with the number of teeth on pinion. That is also they have given 12. So it is a 10-mark question. Quickly you have to do. Can you able to do that, or should I continue? Hello, Chandan. Chandan, can you do that, Chandan?
We'll try, sir.
That is a fantastic answer. We'll try, sir. Others, can you do that? Try, and then so that we can wind up for today's session and then continue this quickly, this problem. But you have to do sincerely. Then only I think. What I feel, most of you are serious. I don't know how that seriousness has come. Whether it is suddenly seriousness has come, or really you are worried about. Because I told, be prepared always for worst case. Okay, so I think exams have come. There is no other alternative. You have to make yourself comfortable. Okay, 1 second. So first I'll just tell material is given. So only thing material that they have given, I'll tell the data. Afterwards you do yourself. So data, can anybody tell me? So beta, this is a helix angle. I whatever I remember I write helix angle. So what is helix angle, Chandan?
15 degrees.
15 degree. Okay, and then alpha, this is a pressure angle. Alpha is pressure angle, that is 20 degree FDI, and Z1 is given, that is 12. What else is given? That is N1 upon N2 is given. So that is 4.25 is to 1. That means N1 equal to 4.25 times N2. Okay, so I'll just show that. So it is a speed reduction basically. Okay, so it 4 is to 1 means how we can write this. I'll just show that. I'll just show this. This is 4.25 divided by 1. So that is N1 equal to 4.25 times N2. Okay, you cross multiply. What does that mean? N1 will be rotating 4.25 times higher than N2. That means N1 is at higher RPM. It is at higher RPM. N2 is at lower RPM. N2 is at lower RPM. N1 they have given. N1, what is the value? I'll write here. N1 is N1. 1800 RPM. 1800 RPM. So you can find out what is N2. What is N2? So that is N1 by 4.25. 1 second. N1 by, so N2 equal to N1 divided by 4.25. Chandan, can you help me out? Chandan,
423.52. That's
4
point
point
52.
0.52. Others, please check parallelly. 52. Okay, you can round it off. You can round off to 424. Okay,
Okay, sir.
0.5. So, okay, you can round off. I think there is hardly any this thing problem. You can round only Z equivalent. You can't. Okay, 424 RPM. It is N2. Okay. So what else is given? So material is given, that is C30, no? Heat
Yes, sir.
treated.
Yes, sir.
Okay. Both are same, they are told. Both are same, they are told, or different material.
Hello.
Chandan? Yeah. Both are same material or
Yes, sir.
different material?
Same material.
Same means, so design criteria step number 3, you need not have to do. It is opinion. So only thing from the table you should check what is sigma D. Of 12.7, same table you have to see what is sigma D. And heat treated, there are two, unheated, non-heat treated and heat treated. C30. C30 is there, Chandan? 12.7
Yes, sir.
table. What is sigma D? What is
Excuse
sigma
me,
D?
sir.
Yeah, please. Please,
So in
please.
design procedure, you have said to refer 12.22, sir, page 241.
Okay. Correct. Thank you. I think for spur gear, you are right. There is a separate table. Separate.
But
That just
ಇದರ ಮೆಥಡ್ ಕೊಟ್ಟಲ್ಲ.
ಅಲ್ಲ ಟೇಬಲ್ ನೋಡಿ, ಟೇಬಲ್ ನೋಡಿ, ಅದರಲ್ಲಿ what they have given, that helical gear, you are right. Helical gear only, I think. Helical gear, no? The title of the table. 12 point, what is that?
Yes,
Hello?
bone gear.
12 point?
22.
One second. 12.22. Page number?
241.
241, na? Correct?
Yes, sir.
Okay. So I think you read the title of the table. Is it for helical gear he has written?
Available static stress for helical and herringbone gears.
Helical and herringbone. Herringbone is a double helical. So I beg a pardon. You are not supposed to refer 12.7. In this case, you have to refer this one only. You have to refer this table only. Thanks. Who has updated? That's what I told. Actually, I left my data book and then, so in a hurry I told. So do not refer the spur gear. Okay. So you have to refer this table only. 12.22 page. I think in the design procedure I have given, but I just forgot myself in a hurry. Okay. So please refer that. And what is the value? Sigma D. So I think who has told that? Who has told that this table? Name? Hello? Huh?
Aprame, sir.
Aprame. Can you just tell what is the value sigma D? Referring that C30 is given there or no?
Mentioned the C30. No, sir.
Huh? That 0.3% carbon is there? Somewhere
0.4 to 0.5% carbon.
I think, I think that is a mistake I did. I think in a question paper also, I think that was a problem probably. Just sometime, no. If it is not given, don't be panic. What you can do, either you can refer back spur gear section with a note. Always remember, design means you may laugh actually. It is a judgment and then visibility and then your intelligence to decide if some material is not given in the table. Okay, in the academics, don't be panic. Simply write a note, this particular is not given in the table, so and so forth. Hence selecting the next material, you can go ahead, or if you are very particular, you can either take the C30 material from helical, that is spur gear section as well. Okay, so some of you do, we will debate this tomorrow. Some of you do with the C30 material. Okay, that is C30 material given in spur gear section. Okay, we will check that. Some of you do, what is that next available? You told Aprame C40 or 45?
0.4 to 0.5% carbon steel heat treated.
0.42% carbon heat treated. Correct? Correct? Aprame?
0.4 to 0.5, sir.
0.425. Correct?
No, sir. 0.4 to
From
0.4 to
Point?
0.4 to
What?
0.5.
0.4 to 0.5. 0.4 to 0.5. Okay, fine. I understood. I think this is not 0.4 to 0.5% carbon heat treated. I think they have given. Some of you do by this, some of you do by this. Okay, this is going to be the assignment for today. So tomorrow randomly I will call whichever you, please don't copy. Please you assume the corresponding sigma d. It is a small, very small problem. You check till sigma induced. Okay, find the module and check sigma induced. Okay, here we will stop. We will stop here. Is that okay? Is that okay?
Yes, sir.
Yes, sir.
Okay, fine. We'll just stop. So I'll just stop here. Okay, we will continue tomorrow. And this problem, hope all of you have taken, or still anybody. You can take a screenshot. You can, if you want, you can take a screenshot. Okay, screenshot you can do in a mobile. So this particular whatever that highlighted, this is a problem. If somebody has not taken the problem, you can take this this thing and then try to solve. Again, don't this thing tell. Okay, tomorrow I have the class at 9 o'clock. We will meet exactly at 9. So I request be there well within the time. Okay, so we will stop then. I will close this. Chandan.
Yes, sir.
Okay, thank you one and all. You
Thank
can
you,
leave. You can leave.
Thank you,
You
sir.
can leave that record. I'll record. I will just put it in the YouTube and then share you immediately. Okay. Thank you.
Thank you, sir.